most of the time you're going to see a radius or part of a radius. So if a diameter or radius is perpendicular, real important, perpendicular to a chord, then and you investigated this, then it's going to bisect the chord and the arc. What does bisect mean? Make it into two equal parts. In other words, we could go way back and say that that diameter is a perpendicular bisector of the chord and the arc. In a circle, if a diameter radius bisects a chord that is not a diameter, then it is the perpendicular bisector to the chord. So, I mean, that second one is not that important. It's the first one that's really important. So if you see a radius perpendicular, you know this segment is equal to this segment. You know this arc is congruent to that arc. The arc does not equal the segment, but the arcs equal each other. So with that little bit of information, number one on last night's homework, all of a sudden is really easy. Yes? No, all you have to do is write its new equation. So this is what I need to do. I mean, if we're perpendicular and it cuts a segment in half, it's called a perpendicular bisector. So this is kind of a statement based on that statement. So I think as I go through my examples today, it's going to be a lot like the worksheet. All right, so if I see a radius or a diameter perpendicular to a chord, what will you look for? What are you going to look for? Equal segments and equal arcs. So yesterday, if we had congruent chords, we had congruent arcs. We had congruent central angles. So now if I know that the radius is perpendicular to the chord, then I know the chord was bisected, and I know that was a single one, and I know my arcs are bisected, or my arc was bisected. Again, I want to picture a diagram on each problem on tonight's homework. You want to do the chord worksheet 1 first. It's going to work with this. And then what I did on chord worksheet 2 is I gave you congruent chords with perpendicular segments. All right, so let's just read the directions. And again, D is the center of the circle. BD is perpendicular to AC. So if BD, this radius, is perpendicular to AC, that's a right angle, what does that tell you? Two things. What does it tell you? That arc AB and arc BC are congruent. What else? AE and EC. So if they tell me that BC is 70, I'm not even looking at what I need to find. Let's just talk about what we know. If this arc is 70, what's AB? 70. If AB is 70, what's angle 1? Vertex on the center, 70. Central angle equals its arc. What's angle 2? Okay, so what if I asked you what is angle ADC? 140. What if I asked you for arc AC. What if I want to know that angle? You know that's 90 and you know that's 70. What do you know about the angles of a triangle? Pardon? They add to 180. So we would say 90 plus 70 is 160. 180 minus 160 is what? 20. Look at all I could ask you just based on that. Could I ask you for this arc out here also? Did I do that on your worksheet? Yeah, I did. So if this is 70, you know this is 70. How do I get this green arc? 70 plus 70 is 140, and then what? 360 minus 140 is, I think, 220. Okay, I have no clue what I asked, so let's go see. I asked for the measure of arc AB. What is AB? 70. But look at what I could ask on this one diagram with that one piece of information. So either I make a really, really long review and ask all of this, or I just hope that you've done enough problems we can do this. All right, so I need another diagram. I like to mark up my diagrams. All right. So here's my new diagram. AFC, that's an arc. AFC is 300. So if from here all the way over to here is 300, how in the world am I going to find out what this is from here to here? So the first thing I'm going to do is I'm going to say 360 minus 300 is 60. If this whole arc is 60, what is AB? 30 BC. 30, what's angle 2? What's angle 1? All right. We want angle 2. What's angle 2? 30. 60 divided by 2 is 30. Okay. Let's get a new picture. Don't you wish you could do that on your homework? Just clone it? Caitlin. Because the yellow is 60. Okay, and what does a perpendicular radius do to the arc? Bisect it. So if it's 60 from A to C, what should it be from A to B? Does that help? All right. Now they're telling us angle 1 is 44. What's AB? 44. Now this is perpendicular, remember, so what's BC? 44. What's angle 2? 44. What's this angle? No. What do we know? What is this? So what? It's a triangle, right? So we would say 90 plus 44 is 134. 180 minus 134 is going to be 8, 7, 10. How about 46? Did I do this on your worksheet? Yes, I did. Numerous times. Anyway, we want the measure of CFA. CFA. In other words, what we're supposed to find starts at C, goes all the way around to A. How am I going to get the blue if I know that this is 44 and that's 44? MJ.
Add 44 and 44.
So 44 plus 44 is 88. Then we're going to take 360 minus 88 is 6, 5, 10, 2, 3, 2. How about 272? So as I've gone through and looked at everything I could look at on this picture, I have covered pretty much every problem on the homework. If you make a note on problem 2 of the first worksheet, is it Samantha or Caitlin or Sydney? That it says measure of, what should that arc be? kgh. All right, you need to insert the g. I left out the g. It's 240. If an arc is 240 degrees, it should have 3 letters. So just make that notation so you'll know which arc I'm talking about. It's on chord worksheet 1. Number 2, it says arc kg. That should be kh. It should be kgh. All right. So now let's see what it says. It says D is the center of the circle, and it's saying that DB bisects AB. DB bisects AC. So if DB bisects AC, then what do we know about the arcs? They're congruent. What do we know about these central angles? Why must the central angles be congruent? 1 equals AB, 2 equals BC, and what do we know about AB and BC? All right, this is a theorem that you learned a long time ago. What do we know about AD and CD? What do you know about those two segments? They're congruent, yes. Why, Kayla? What kind of segments are they that start at the center and stop on the circle? What's that called of a circle? Radius. And what do we know about the radii of a circle? Do they change? They're always the same. So if these two segments are congruent, that means the endpoints, we've got a segment that is equidistant from the endpoints of a segment. It's not only bisects, but it's also perpendicular. All right, so let's look to see what we're given. We're given arc BC is 6x minus 1. We're given arc AB is 4x plus 19. What equation are you going to write? Four x plus 19 equals 6x minus 1. How do we solve? Nick, how do we solve? You look sleepy. Subtract 4x. And we're going to add 1. So you're going to get 20 is equal to x. What is x equal? 10. They want you to find the measure of ADC, an angle. ADC. I need either the measure of angle 1 or the measure of angle 2. Which one do you want to find? Becky, you want to find 1 or 2? Okay, and 1's measure is the same as what? Same as 2. So you can either use 4x plus 19 or you could use, which would you prefer? All right, so we're going to say 6 times 10 minus 1 is equal to 60 minus 1 is equal to 59. So if 2 is 59, what's 1? 59. So what's the measure of ADC? 59 times 2 is 18, 10, 118. All right. So we're going to come down here. It says AC is 16. If the length from A to C is 16, what's the length from A to E? 8. What's the length from E to C? 8. They're telling us DC is 12. How do we find the measure of ED? Not angles anymore, it's sides. Pythagorean theorem, because that is a right angle. Let's let this be x. You want to go ahead and set that up for us, Devin? 8 squared. Okay, and you did a great job in doing leg squared plus leg squared. You have the numbers in the right order. So you got 64 plus x squared equals 144. I think when we subtract 64, you are going to get 80. So what happens now? What do I need to see? How do we get x by itself? Square root. If I square root this side, I have to square root this side. And how many answers do I get? 2. Why do I need to see this? Algebra 2. Which answer will we choose? Square root of 80, which is approximately 8.9-ish. Because 9 times 9 is 81. Yes, ma'am. Mm-hmm.
Wouldn't BD be an angle bisector of ABC?
It is. BD is an angle bisector. Okay, I mean, this is just so rich with stuff I can do. D is the center of the circle. DB bisects AC. So bottom line, I can tell you one of two things. I can tell you that DB bisects the chord, or I can say that DB is perpendicular to the chord. Either way I say it, what does that tell you? The chord is cut in half, the arc is cut in half, the central angle is cut in half. So we've got angle 2 is x plus 1. Measure of arc AC, that's all the way across, is 4x minus 22. If this angle is x plus 1, what is this arc right here? X plus 1. What is this arc over here? What equation will you write now? Right, so don't assume that everything is going to be 1 equals the other. Why can't we set these equal to each other? What prevented that? I gave you the whole arc, not what? The part, correct. So let's see if this is a good problem. You got 2x plus 2 is equal to 4x minus 22. Kayla, Abs, how do you solve? I lost my cursor. Okay, subtract 2x. I can do that. Then what? Add 22. So we're going to have 44 is equal to 2x, then what? And you're going to get? Huh? I did a really nice job multiplying. Ooh, that's big. Okay, try this again. We are adding, not multiplying. How about 24? Then what are we going to get? 12. I need BC. What is BC? X plus 1. So BC, arc, is going to be 12 plus 1, or what? 13. And that's degrees because it's measured. All right. The last thing we talked about is the fact that if we have two congruent chords within a circle or congruent circle, chords equidistant. That means from the center to the chord, this distance right here is going to be the same as the distance right there. From the centers are, let's see, within a circle, the chords equidistant from the center are congruent. The converse within a circle or congruent circle, congruent chords are equidistant from the center. So if I didn't tell you, what I just showed you was the second one. If I tell you that CD and A, I don't know, B, if I told you those chords are congruent, then you know, and that this segment is equal to that segment. If I tell you that this segment equals this segment, then you know the two chords are congruent. So it goes two ways. This is the end of section 12.2. This is the last part. These are you investigated all of these before break on that Friday. And Tommy can pass back paper so you have your investigations. All right, so here, if I see chords equidistant from the center, I will look for equal chords. That means CD is equal to AB. And of course, then if you have equal chords, that then implies that arc CD is equal to arc AB. We're red. Okay? And to be equidistant, that is inherently perpendicular. So if this is starting at the center, I'm perpendicular to the chord. What did it do to the chords? What did it do to the chords? If you're perpendicular to a chord, it split the chord into what? Two equal pieces. But those pieces are going to equal those pieces because ultimately our chords were equal. The relationships are just unbelievable. All right. So I think what I'm trying to do here is summarize. Two congruent chords in a circle determine two congruent central angles. Determine two congruent arcs are equidistant from the center. We had that triangle. Congruent chords look for congruent central angles, congruent arcs looks for congruent central angles, congruent chords, congruent central angles look for congruent chords, congruent arcs. But if you have congruent chords, you also know this piece of information. So if they tell you the measure of ACB is 65, and you know that chord is equal to that chord, what's the measure of AB? Central angle, 65. What's the measure of ED? 65, because congruent chords have congruent arcs, so that's 65. And so now what is angle ECD? ECD, what is this angle? 65. $16, MJ? Can you get your license today?
No, I was before.
Okay, so now you're being told that chord AB is congruent to chord ED. So if AB is congruent to ED, what do we know about arc AB? What do we know about this arc? Jeff? This chord is equal to that chord. So what does AB equal? The arc. Oh no, don't even look at that. Don't look at, yeah, we're not looking at any of this right now. But if this chord is congruent to this chord, what do we know about this arc? It's congruent to what? Right, this arc down here. All right, if you see this perpendicular, what do you know about what happened to each one of these chords? Brittany Norwood? If you see a radius perpendicular to a chord, what did it do to the chord? It cut it in half. Okay, and what did this radius perpendicular to that chord do? Cut it in half. Now, why did I put the same tick marks? Why didn't I put 2 here and 1 there? What do we know about the segments to start with? They're congruent. So if this big segment's congruent to that segment, do you agree its halves are going to be congruent? Okay, what did this radius do to arc AB? Caitlin? Okay, if you have a radius that's perpendicular to a chord, what did it do to the arc? I'm sorry? Okay, so explain more. If we've got a radius that's perpendicular to the chord, what did it do to AB? It split it in half. All right, do you see how there's that blue highlighter and this blue highlighter, which makes those arcs equal? Why can't I put double tick marks here also? Right, because ED is congruent to AB, then when it gets bisected and this gets bisected, its parts are going to be equal. Lots of relationships here. By the way, what do we know about HC and CK? They're equidistant, which means they're what? They're congruent, and that's to this part. All right, if AB is 16 from here to here, what can you tell me about AH? Karen, if this segment is 16 from here to here, what's the length of AH? Okay, the whole segment's 16, 8. So what you did is you said 16 divided by 2, correct? All right, because it got bisected because we've got that perpendicular. If angle ACB is 44, Brittany, see what is this angle right? Oh, I lost it again. What is going to be angle ACH?
22.
22. Oh, I just got a new. Okay, so this is going to be 22. Let's try this over. Okay, this is going to be 22. What is this one? 22. All right, if this angle is 22, what is this arc, Carlin? 22. And if this angle is 22, what is this arc? 22. Well, let's see. Eric, what is this arc right here? From E to G. What's that arc? Right, and this is why. You've got AB congruent to CD, or ED, which means this arc is congruent to that arc. So if you cut this arc in half, that's equal to this arc, don't those halves have to be the same? Yeah. So what is this arc over here? 22. So what is this angle right here? 22. What is this angle right there? 22. How do we find that angle right there? What do we do? 90 plus 22, then what? Subtract it from 180, 8, 7, 10, 8. That would be 68 right there. What would this be? 68. All right, anyway, we want the measure of AF. Did we just find the measure of AF a long time ago? Now, CK is 6. Where's CK? You know what? I'm going to pull this picture. They're telling us that, ooh, come on. They're telling us that CK is 6. They're telling us AC is 10. Now, this is classic. I want everybody to look at this. Do you see how 10 is in a different triangle than 6? But what is AC? What segment from the center to the circle? It's a radius. So what does that mean CB is? 10. What does that mean CD is? 10. What does that mean CE is? 10. You see, as long as you have one radius, every radius in the circle is going to be the same. Do I have 6 and 10 now in the same triangle? All right, so we want the measure of ED. We want the measure of this whole segment. Well, I got news for you. We're not going to do that right away. Do you see this triangle right here? How are you going to find the measure of EK? Pythagorean theorem. We're going to let this be x. So who wants to set this up for me? Leslie, you can set this up. Pythagorean theorem. Pardon? 6 squared plus x squared. Exactly. So you're going to have 36. You picked up the legs, squared them, added them together. So now you're going to subtract 36. And so what is x? How do we solve this? Travis, what are we going to do to get x squared by, or x by itself? And what do you do when you square root? How many answers do you get? 2. Got to see that. Why do I have to see that? Algebra 2. So what is the square root of 64? 8. So if this is 8, we did a great job, but they asked for ED. What is KD? 8. So what is ED? ED is 2 times 8, or 16. I probably could write 50 questions based on one picture. Okay, so now F is the center. We know that this chord CD is equal to chord AB. What does that mean about from the center? Yes? Okay. So what do you know about these two segments, EF and FG, if these chords are congruent? They are equal. So if you know EF is 5x minus 7, and you know FG is 2x plus 11, what equation do you write? All right, and what told you that? What told you that were all those relationships that are in those investigations. If we subtract 2x, we get 3x minus 7 equals 11. We add 7, we get 3x equals 18. What does x equal? 6. Did they ask for x? Yes, they did. Okay, if CD is 20 and CF, now, CF, do you see CF up there? Draw it. I don't see it, draw it. CF is 15. Find FG. They want you to find this segment, but what segment are we going to find? We're going to find EF. Why is finding EF sufficient? Because it's equal to FG. If this whole chord is 20, what is this part right there? 10. What is this going to be? X. How do we find X? X squared plus 10 squared equals, 10 squared is, that's a plus. 115 squared is 225. Subtract 100, what do we get? This is going to be x squared is equal to 125. What do we do next? How many answers do we get? 2. So x is equal to, we're going to choose the positive. It's going to be 11 point-ish, something or other. All right, so we're going to pretend, for all intents and purposes, I want you around the hundreds place. We're going to pretend that it's 11.20. So if this is 11.20, what is this? 11.20. So you have everything you need. And basically, equal chords have equal arcs, have equal central angles, are equidistant from the center. If you know you have a radius perpendicular to a chord, it bisects the chord, it bisects the central angle, it bisects the arc. Oh, and then this is going to be fun.